Alright, so last time we were able to implement rule 110 in stack language, which is, kind of a nice achievement. And what we noticed is that it would be extremely nice for like ease of development if we had type checking, already in our stack compiler, because we had so many bugs that could have been avoided if we had type checking, because doing this thing manually is kind of difficult. And I mean, you'd still have to do it regardless, but at least you know it's correct, right? So, and the type checker will actually tell you where your mistake is. So I'd say we should start with that. And something that I believe we need to add first, because let's say that, like, one thing that bothers me when I have to implement stuff in assembly directly is that it's gonna be missing from this stdlib.sl file, right? So we don't have a definition for dupe, we don't have a definition for swap, so it's kind of, you rely on the documentation to tell you how the function looks like. But I would like to have some way of putting these like extremely important functions, like the basic ones like dupe, swap, and so on. Let's try to put them somehow into the language, and I was thinking to use the same approach with the external keyword. So if you put external here, it's gonna skip the entire function, right? And yeah, I mean, the point would be that the assembler knows that it's not supposed to like do anything with this function, but the type checker will know that, okay, this function is defined, so if we find it anywhere in the code, right, we know its definition, so we don't have to explicitly type this definition in the code. And I think that's gonna be much nicer. So what I'm gonna do actually is go to where we emit the assembly, and at some point we emit keywords, right? So we do dupe. I guess it's gonna be easier if I just look at these definitions, right? And also the data types, right? The data types, I think it's gonna be important. Like usually you have like iVec2, int x, and int y and whatnot. And what if we do int external? So instead of the body, you have this external data bool external, data string external, and it's gonna be data memory external. But I think we'll keep memory for a bit, like it's gonna be part of, first let's make sure that it works with int, boolean, strings, right? And then we'll come back to what uses memory, because I think like I want to try to do that because memory is gonna be a bit more interesting. Like maybe we'll try to add the concept of something like this, where you can have type variables or something, right? So for example, let's say you have a tuple and it has, like, it's gonna be a type A for the first and type B for the second, but here it's like, what is A and B, right? So maybe I'm gonna do something like this, right? So you can actually parameterize the tuple. So then in a function that, let's say, I don't know, it returns a tuple, you would say tuple int string or something, like it returns an int and a string, right? So maybe we'll have something like this. So yeah, so let's leave memory for now, and maybe we'll add that thing, like we'll see. So let's go back to main and try to add all of these, right? So function main, you have to define it yourself, so that's not important. Swap, let's add swap ab and be a, and even these functions that are generic, they are going to be interesting to figure out. So yeah, let's see. Rotate prime. No, I'm curious. Rotate prime, isn't it just two rotates? A, B, C. So this one is rotate clockwise. So B, C, A, right? External. And if I think about it, right? A, B, C. This one is C, A, B. So yeah, it is rotate twice, if I'm not mistaken. So I could just say rot prime A, B, C. It's C, A, B. It should be just this. I think. Like, we don't even need to define it here. It's probably gonna be just rotate prime like that. Wait 1 second, let me just remove all of these. Let's make, and let's try to run this thing again. It works, right? Yeah. That's kind of a cool find. I mean, sure, if you think about it, if you implement a function directly in assembly, it's going to be more efficient because reasons, you know, it's a bit more efficient, but yeah. And another important function, I think it's pop, a function that ignores the item. So I'd say that these, like, you cannot define these four functions in terms of other functions, right? They are the building blocks of this kind of language. So yeah. All right, and then these are, you know, helper functions, and then we have math functions and boolean and whatnot. We can say math functions, or I guess it's int functions. Right, but that means I'm gonna put all of these there. So let's see. I'm just gonna copy something like this, and then let's add the plus, which is gonna be int returns int, and then we have a couple of them that are like simple, all the same, right? They're all the same for these kinds. And then we have these comparison functions. And yeah, I don't think it matters if I do that or not. So let's add them here. And then we have function less than, you can see it. Okay, I mean greater than, I guess, which is still for integers. less than equals, right? And then we have a few functions for string. So this one is string.out, is gonna take in a string and doesn't do anything. String length int, string concat merges to strings, and string substring is gonna be int string, right? It generates the substring. So these are all the external functions, and I think for string is the same idea. These should be like, you cannot really implement these in terms of other functions, like making the concat of two strings. It needs memory allocation. Substring, it's same thing, and len needs to access the length, which I mean could be done, but I think it's better like this. Okay, so let's go to the top and let's try to add define slice external. So I said external. I think I'm gonna call it extern because it's shorter. So let's make a string slice extern. Yeah. Okay, so that's gonna be extern, right? And let's add it here as well. Right, so that's that. And we have to check here. So we check for ifs, for anything, for like all kinds of words, and at some point we have to check for external, which I mean I call it extern. So, and if it is extern, we just create the extern token. That's pretty good, right? So if we go to tests for Lexer, we can add 13. Oh shit, it's 13. Extern.sl, and we can define some data, something extern, and function stuff, I don't know, like something int extern or something, like just to have some data to test. And if we run mix run, we should see that everything passes except that test, I would say, the 13th one. Yeah, perfect. So some tests failed, we have to fix it, right? So let's make main tests 01 13. I think I have to run the Lexer. Right, so that's how it should look like with the extern keyword. And makes sense. Extern.ref. Let's see if it's correct, right? So it's data name and then extern function blah 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 extern and then the file. Looks good to me, to be honest. So what are we gonna do now is go into main.c. Let's go into the parser, right? And we have to make sure that when we parse the data or the functions, that we kind of allow, for example, these fields to be empty, and at the same time maybe we want a flag boolean extern. Oh, extern, right? So we want to know if it's an external definition in a way, right? So here we parse a data, and here we take data, right? So basically here we expect an L parenthesis, right? But it's actually kind of two cases. It's like if token kind is equal to stack token extern, we do something, and on the else case I guess I could do an else if, wait, no, I mean I can do a return defer 0 here, right? So it's just return defer, and then we can just say all of this stuff safely. I mean, we could do something like if it's equal, then we do a big if case, and then on the last case we say expected extern or L parenthesis. Right, like we do something like not doing that error yet, we do it at the end, and then we take all of this stuff and we put it inside of the if statement, right? And then we can say expected to L parenthesis or stack token extern and whatever recovered from error, we don't really care. So I mean, even if you want to have something like this so you can see better, right? We have 3 cases. Looks good to me. All right, so if we have an extern token, here you can see that we append to the fields something. Well, we don't really do that. We just do something like data extern is equal to true. And in this case, we say it's equal to false. All right, so we might do something different when it's extern. Right, I think that's how we are gonna read data. And now let's see how we are gonna read functions. So here we have some expressions, I don't care about them. We should have functions at some point. Here. Again, we'll have a boolean flag for extern. And we are gonna set the body to be empty. And see how here we used stack.st node for the types. I think we'll have another stack.ast thingy, like stack.ast type, which can have like generic, parameterization. So that's what I'm planning to do, to replace this ast node with ast type or something. So you can have stuff like memory int, like it's basically an int pointer, but we'll see. So for functions, we initialize some arrays, That's interesting. Did I initialize the arrays in data? That's I don't know why I'm checking that, but bear with me. Yeah, we do. Anyway, let's go next. So at functions, what we want to do is to parse the function nodes, so the arguments and returns values. And here we look for the in keyword. But again, there are two cases, or I guess three cases. If we have stack token extern, we are gonna do something like function extern is equal to true and return differ 0. Then else if the token is in, we are gonna do the do while loop. Right, let's do the do while loop. And I guess point is we already have some recover from error here. Hopefully it's gonna still work. Right. Expected to stack token in or stack token extern. So we expected one of these. And I mean, if we already failed, then we failed. So, but, that's interesting. That should be on the else case. And it should be here. Okay, see the place where using else ifs actually helped, like in this case. Okay, so that's how we allow having external functions. That's pretty good. Okay, and let's see where we print all of this stuff. We should have a printing, yeah, here. So how are we gonna do that? I think I'm not gonna put a new line here, and I'm gonna say if data is external, I'm gonna do fprintf std out, and I'm gonna do extern. Right, and then fprintf a new line dot to std out. Right, so we do std out and we print the extern keyword in case it is external. And I mean, it won't have fields, so that's something we don't really care about. So now let's go to the function. So arguments that I think I'm gonna do it here. Makes more sense. Func. Right, and we do extern, and then we show the types, the return, and the body won't really be shown. The body won't really be shown if function dot extern, if not function extern, we show all of these. Right, and yeah, maybe I can also do it here just to make sure. Right, so now if we try to run make and we try to parse this thing, we can see that data and function are external. That's okay, I guess. If we run main on examples, 0 1, is it still gonna, yeah, it's not really gonna work because it's gonna say, oh, symbol is already defined. So the next step even is, let's go to the, not preprocessor doesn't really care. Let's go to the assembler, and at some point in assembler we emit a program, and the emit program does emit data, which is going to generate all of this stuff, and it's also going to do emit function, which is going to generate all of this stuff. But I don't think we want to do any of these for the external functions or keyword, like anything. So if it's not external, we emit it, otherwise we don't. So that's what I think I'm gonna do there. And it prints hello world, right? That's cool. And you know, the issue is that it emits the same function that we define here, right? Like these functions. So all right, we have some progress, right? We added these external functions, so lib, and I guess the point for them is to build the context. So let's try to start on type checking now, because that's the external keyword was added, and yeah, it makes sense to now do some type checking. So let's see if we can actually figure how to do some, at least, you know, for pluses or something like that, really simple, some basic type checking. So yeah, let's see if we can do that. So I guess the first step for the type checker is to build this context, right? And I left some comments, but we'll try to figure out together what the context is, and then we do type check, right? Yeah, I mean, it's still work in progress, right? We don't need a file name here. Because the file name is on the AST itself, so yeah. And I'd say the context is gonna be the output, kind of. So yeah, I'm gonna keep it here as an output. Well, I mean, context could be part of the type checker, right? So I could do that as well. But yeah. And then you just do typechecker.context, but I mean, I don't know. Like this idea of having a variable for that, but anyway. So we have context in it, right? So context should probably have a list of functions and data types, right? Or at least, yeah, or at least a list of functions. But even the data types could be important. Although, yeah, I'm not sure if data types, I don't think it matters the fields. I think it only matters the names of the data types, and functions, you know, only matter with the input types and return types. So yeah, I mean, I really think that context should be part of the type checker in that case. Or at least not here, right? Or at least not here, and maybe we initialize the context inside of Typechecker check, right? So yeah, that's what I think. I think we need a list of the types and a list of the functions in the context. So let's try to have those things. So might be a dynamic array of types, or I guess datas, how I called it in the assembler, right? In the AST. So let's just steal these. And as I said, we might use not. Oh, so here I used AST data and AST func. But again, I don't plan on doing something. I plan more on using node, right? So here I used AST data. But again, here I might want to change this thing into stack AST type, for example, instead of node. So we'll see. But for now, let's keep them as stack AST nodes. Or not even, maybe even string slice actually. Right? I mean, I was saying that for the stack AST data. And stack AST function. That here I might want to change this into something else, but yeah. Anyway, yeah, I think slices is fine for data because, as I said, data needs only the name of the functions, or I guess the data types. But for functions, I think we need more. I think we need the name of the function and arguments and outputs. I think that's what we need. So again, I would maybe even type def struct, even have something like stack context data, and this is gonna be string slice like name, for example. So we have a wrapper type just to not worry about later. And here we have stack context func. Stack context func. And the function is gonna be name of the function. And then dynamic arrays for the types. Dynamic array. So it's like stack st func. Args and reds. Right, we have dynamic arrays for the args and reds, and these should be string slices, although I'm not sure if they're going to be string slices or not. But what I'm gonna say is that the context is always gonna be correct, so it's not gonna need error handling. So I think that's good. Okay, so stack context data free. We should have stuff like stack st func free, right? Yeah, so we have these kind of functions. Stack context data pointer data. It's just gonna do this string slice free data. Well, I mean, I used holy. Okay. But yeah, for function free, it's gonna be like this. So let me just context func free, and this is gonna be context func. This string size free, obviously. It's gonna be a string slice. I think that looks good. And then we can have a ret in here for the rets. Right, and we don't have a body. So that's gonna be our stack context data and stack context func data structures for our context. Okay, and stack context init. Right, we are just gonna do ds dynamic array init, and I'm gonna do address of context datas size of stack context data and functions func. We don't really need to manually add all of these anymore because they are part of that sounds good. This one, adding new functions and data, that's fine. And stack context free is gonna be stack context data free context datas. Well, it's a dynamic array. Yeah. So it's gonna be something like this. Context datas stack context data. Right, we just free it for now. Stack context data free. Right, so this is more like it. And we can just reuse that for loop for the functions. Right, so we take the func right out of functions. Okay, and we free the funcs. Perfect. So I think that's okay start for the context. Sure, it's a decent idea to have like add new function or add new data, but we can add those once we have something. So what is the type checker actually gonna have in here? I mean, I don't know, because it doesn't really need anything, right? I'm gonna do something like a just to have it. Maybe we'll need something, but not sure. Right, so I don't free the context here, if you can see that. I think we need to free the context first and then the type checker. So tag, oh my god, context free context, right? So what are we gonna do in this case when we implement stuff? Well, I would say the first step is to go through the program AST and find all the definitions. So I'd say that's the first step. So I would do for, and let's do functions first because functions should be the easiest to add. Or I guess the data definitions for adding new data types. I think that's also important. Right, I guess. I don't know. So let's try to add, to go to the data types. Assign int I is equal to 0. I should be less than program data's count. Right, so we iterate the data types, and I'm just gonna reuse the assembler emit thingy for program, and I'm just gonna steal this thingy. So I'm gonna put it here. So we need something like this. Right, it makes sense. So we create a data, we take it from the array, and what are we gonna do is, I guess I forgot to call here stack context init. Right? Makes sense. So here we should say something like stack context data append or something, and then we give it the context and data name or something like that. I think that's what I want to have, or maybe append data or something. So let's add this stack context append data ds string slice name, and it's just gonna be something like ds expect ds dynamic array append context datas and the address of name or something. Shit. ds error out of memory. And this is an AST node, so I would say value. I think this should be fine because I just copy it in a dynamic array append, so I think this should be okay. But again, it's kind of useless to have that function, to be honest. like sure, whatever. So that's how I would add the datas, right? Regardless if they are, let's say, external or not, I would still add these datas. All right. Maybe the only thing that we have to do is to check if the data already exists, because if it already exists, we should show an error. So maybe that function was a good idea after all. Right, so it's something like this function should, oops, be actually an integer, and first step would maybe be to do a for loop. I is equal to 0, I is less than context data's count. We probably want to do a get like this or something, but for dynamic array, let's call it item context data item, and we can do string slice equals. We already have some examples, right? And here we can do basically name and item. Oh, this is a string slice. That's very what? Oh, just like that. Okay, so we just compare them, and if we find the item already, it should return defer one, right? So it's like didn't work basically. So we failed to add the item, so it should show an error for this thing. And here we just successfully add it. So here, if this thing is not 0, so okay, basically we have to show an error. And we have those stack show parser show error. Right, and we give it show error. So we have syntax error. But I want to show like semantic error or something. But still, the parser is important for I mean, the function is useful. We can just take it from here and I don't know, like put it somewhere here. let me just do a bit of moving things around. So this would be stack type checker show error, and I still think it needs the parser, right? Line column, we don't need a token, or do we? We need some token, yeah, that's true, or at least some position. Do we have something like that? Do we have data name dot position? That's funny. We have position, so we can show it on AST node. Right, we can do like AST node maybe. Or we can even have unsigned int pos for the position. Right. Then we can show the file name, we can show the line and the column, and then on the last case, there's the actual error. And it's like semantic error, and then we show it. So I think that's how we are supposed to do it, maybe. Right, and then we can make up stuff like, because the parser is part of the node, right? So we can do stuff like define show error for what, like show stack type checker, maybe like error and data exists or something, and this should be the node that shows the error, and that's kind of it, right? Because then we just need to say stack type checker show error. I can even put it as node parser node.position, and you know what, I'm curious. Cool compiler. What error message did I use in not just in assembler, in semantic stuff? Class, or like it's already defined? Oh, so it's like redefined. Data is redefined. And I can do something like data is redefined, and then we can do node dot value dot len node dot value dot str without the, so I can do something like this, maybe stack type checker, and the node is data dot name. And so this one is gonna do data name parser, data name position, So data is redefined, and wait a second. Yeah. So I think that's the error I want to show if you redefine data. Okay. Data exists. So what next? If it fails, we just ignore it, right? And we go next. That's how I think this works. So maybe failed, right? So, whoa, what? Failed is equal to, I mean, it could be a boolean. Or like a 1. Typechecker failed, right? So that's the return code of this function. Okay, so let's see if it still runs, right? Like it should still work, I think, because we don't redefine anything. So let's go to tests and do 0, 3, like semantic or something. And let's try to add some tests that test this thing. Data redefined. So that's the first test case. So data ivec2 is like int a, int b. What kind of sucks is that I have to do import stdlib for the int type. And then I can do data ivec2 again, int x, int y, and if I run this, semantic error data ivec2 is redefined. Damn, it's actually working. What? So we have a bit of a type checker right now. We know that on line 4, 6, and it actually got it. Alright, it's actually working. But I have to go to the Nix file and let's add semantic. Right. So if it's semantic or all, we do 0, 3 semantic, and I guess I'm gonna use, let me see, in a main I think it's type check, which is actually minus t. Let's then rename it to type check. So we analyzed with type check in this one. So let's then rename the tests type check. So if we run all the tests, oh, it fails. What? That's strange. So if I diff with tests 03, wait, am I? I mean, I have to do. I renamed the folder. Yeah, I'm like, what? First time I was like, it's weird. Oh, I print to std error, not std out, right? So yeah. Okay, so if we run the checker again, it should pass. I mean, I should run it only on the type check, but yeah, and even the memory allocations are fine. Damn. So yeah, that's pretty nice. We are able to check for duplicate types. That's good. I mean, even like you could even say data int something, I don't know, something x, and it would still catch it, right? Data int is redefined. But okay, this one this one's not good, because why doesn't it show the file where it's from? And why is it in that order? Wait, what? You see that? It's in like 5 and then 1. I mean, I guess it, order dependent, but what? I guess, yeah, probably depends as well on how we run the preprocessor. So for preprocessor, it's a bit shitty, I would say. Because we straight up parse into this prog. But wait, it's weird, doesn't the file name get allocated? Like that's the panic moment. Let's see. I'm curious. Isn't the file name properly generated? Because it's being read correctly, so yeah, it should. So then why doesn't it show it? Huh. That's kind of weird, not gonna lie. Yeah, I guess it's not working how I would expect because of stack allocations here, but again, like, I would say that's the issue. And the other problem is we append at the end of the program. So I would change this one to parse programs. Each one parses its own program. And yeah. So these should be like pointers instead, maybe. And we malloc size of stack lexer, right? Well, it's ds malloc better. I don't know what stackst import is, but whatever. Right, I would make them like this. We get the import. So import, it's literally just the reference. We build that file name. Right. We build that file name. We could even do something like bool file name allocked, if you know what I'm going for. Right, so here if you allocated the file name, you can free it as well in the parser, but no. I guess would make sense in the future if we change this thing. So yeah, basically we might want to do something like this actually. Right, so here we initialize the lexer parser. We run through the parser like that. And here we might actually want to store pointers. So the parsers and lexers, I mean, I said already that they are pointers. Or at least I was planning to use them as pointers, but something happened. So here, this one should actually be a pointer. This one should actually be a pointer. Right, and we ds free null parser at the end. And lexer. So I would also do that. Right, and since we allocated them on the stack, now it's working, right? But see, it's because of the wrong order. So here I would actually maybe parse into a different prog and then combine them somehow. Memcheck still works at least, right? Valgrind, it still works, but it's more allocations, right? So yeah, again, I would say that here I would set It's weird. Dynamic array, because we don't have extend, but we have append, right? So append many, that's another one. Right, which helps, but yeah, I'm a bit stuck. Huh. Because that's what I would like to do. If you use an import, I want to add everything to the beginning, not the end of the program, but currently parse just adds at the end, right? Because it does append. I mean, it's just the fact that I cannot really change the pointer to this prog, right? If I could do that, that would be better. I mean, I should be able to do something like stack st prog new or something like that, and then we initialize it. So I call to stack st prog init. Don't I have a init function? What? I was pretty sure I have a, oh, it's stack ast init. Okay, so init, and I give it prog new, right? So we initialize all of these. It's basically empty. And what can I do with this? Well, it's going into the recursion, putting all the leaves first. So I would just give it here like prog new, for example. So it's gonna be in order, reading into prog new recursively somehow. And at the end, I would just append all of the things into it, right? And then put them back into prog somehow. So something like ds dynamic array append many, and here I do prog new datas, and here I can do prog datas dot items, which is a void pointer. So I need to make address of that, and prog datas dot count. So we append many like that, And I think this one is ds expect out of memory or something. All right, and here we should append to funcs count, and it knows the item of the size of the item because, you know, right, we know the size of the item. Yeah, because we use the okay. So that's how we can do this stuff. And then I should do dynamic array 3 or something probably. But see, like, stack st3 runs a free over these guys. So I could stack st3 it. Stack st3 the program, but I'm afraid this will free too much stuff or something. Field free. But I don't think it will. Or I'm not sure if it will. Stack st free. Right, and then what I would do maybe is program.datas is equal to prog new datas program.funcs, right, something like this, but I'm not sure if this thing will work. It doesn't. And it doesn't really work with this prog new thingy. Don't really have an insert. So I'd like to have some kind of inserting the new programs in the beginning. But I don't know how. So if I run just this thing, it should have some memory leaks because of the prog new thingy. But if I do stack st3 prog new, it should free everything, in my opinion. Yeah. So that's freeing everything. But as I said, the parser doesn't allocate anything, if you think about it. So why does it fail like that if I free my program? I mean, the append many makes sense. But why does its segmentation fault? Because prognew is not allocated, so the stuff is lost, right? So prognew is allocated on the stack. Okay. So instead, I should try to append many maybe from it into my old datas. But for that, what I could do is something like ds dynamic array. Oh, I have copy. That's huge. But this allocates. We'll see if it works at least. So we have dynamic array and then the copy. So dynamic array is prog new datas. Prog datas. I mean, this one should be addresses, but you get the gist. So it's funcs and funcs. Alright, so now we copy it. But it's still sec false. Excuse me? Weird, why does it still sec fault? Hmm. Many. Yeah, like I don't know. If let's say I do this just to test something. So I try to copy into my datas. I try to copy the prog new stuff. So prog oh, I try to copy it like that. And this one still doesn't work. Okay, that's fucking stupid. Yeah, I have no idea why it's not working properly. I could have something like stack st prog. It's annoying. Like have the output program, but this is like C being annoying. Because the point is, I mean, I could do just that, but and call it a day, right? Because it is what it is. Like the idea is, I would like to have a temporary variable for this parse, and then just append that, or I guess prepend that to prog. Oh, I'm not sure why it's so difficult to do that. Yeah, it's a bit strange, but anyway. Like even when I parsed into prog new and then I just copied from prog new into this, it didn't work. So what? Like even just copying from it, it's not working. So like, I'm like, what the fuck? And I initialized it. Okay, maybe let's try something different. Let's say we have prog new as a variable here somehow, right? And we st init it, and at the end we stack st free the program so we don't lose it, or I guess prog new, or no, prog temporary. So we initialize it, so that's not a problem, right? So if we just parse into prog new, like this shouldn't cause any issues. That's what I'm saying, right? It makes sense. But I would like to take this stuff that's now in prog new and just prepend it to our new, like to our old program. So how to do that? Well, ds dynamic array append many. So that's what I don't understand. Like I append many into prog new dot data, so that's the array, and I take stuff from prog, should be still address, prog datas items, and prog datas count. So that's how I'm pretty sure this should just copy stuff, right? Append many. So it reallocs and then it does mem copy. So I'm like, what? It just mem copies stuff. Yeah, it mem copies. So if I run this thing, I mean it should still work because it's nothing changed, but it doesn't. What? Invalid free. Okay, what? Stack st data free, stack st free. 1155. Yo, this one is weird. So it does stack st free, stack data free, and it complains that it's not allocked. After it was allocked. Like, what the fuck? Stack st data free. Maybe copying this shit, it's actually not working or something. Like here it just does dynamic reappend. That's all it does. So why wouldn't this thing work? Like copying from datas. Right, saying that this free doesn't work, it's so weird. Because it copies datas. I mean, fair, that's maybe not allocated actually, but like maybe the point here is not to allocate, like not to free the AST, but to free the array itself, like just the array, right? So maybe that's the way to do this one. Like use prog new just as an array, right? Just use it as an array. So here I free the arrays only. So I only free the datas. So prog new and funcs, right? I just free these things. But it still loses some shit. Quite a lot of shit, if I'm being honest. But that's because I don't copy it back to prog. Alright, so now comes the big question. I parse into prog new, and then at the end I do this append many, or do I do it always like this? Let me think. So if you think about it, I could do it on prog new and just do it at the end. That makes sense. Makes quite a lot of sense, honestly. So let's do that actually. So I just initialize my prog new and I free it here, right? And what do I have to do is ds expect that this works with ds out of memory, right? And right at the end, I should swap their arrays. So I should say something like maybe ds dynamic array temporary is equal to prog new datas, then prog new datas is equal to prog datas, and prog is equal to temporary. And then we can do the same for prog new funcs. Prog new funcs is equal to prog funcs. Right, and then we can easily just free the old array or something like that. Shit. Of course it's segmentation faulted. But why? Weird. I thought I cleared it. It's maybe I forgot something. No, it's 130. Like 100 missing frames, which are coming from this. So why isn't this one working? I just want to swap around the datas and functions. Right? Like what's wrong about this? Because I could just say prog funcs is equal to prog new.funcs. I could say that and just not read. In my opinion, this one makes sense, right? Why doesn't it work then? And why doesn't it work? Stack assembler emit. And it's pretty weird why it's not working. Because we have datas which is clearly initialized as an array, so it's allocated. That's important. It's allocated on the heap. So if I just swap these things, it should work, right? Like prog datas should be much larger, right? If I do printf and then I do it here, I should see some stuff right before the assembly. Okay, I mean I'm gonna do preprocessor 2 and 5, right? It makes sense because I have more. So it, but it fails. Okay, so see, it kind of fails weirdly. Huh. Is it because of this append? The fuck? Isn't the append many supposed to work? Like what? Mem copy new items. Mem copy new items is void pointer. I think void pointer pointer. What the fuck? They just cast it to void pointer pointer. Oh. Right. Because void pointer pointer, it just means in this case it's an array to items, right? And or like a reference to items, but this is already a reference. That's weird. I should make this one void pointer. I mean, new items is only used here, so maybe it should just be like this because it's confusing to have void pointer pointer. it's kind of confusing to have this as a void pointer when it's clearly not needed. Right. So the stuff with temporary was fine. It was just me using the address here instead of just that. And now it frees everything. So weirdly enough, it's less allocs. What? Oh, because I'm doing -p. See, now it's 11 more allocs, which is more allocations. But I think should still work, right? Let's see. I mean, it still works. Mix around checker. The last one doesn't work because now if we run main on tests, we should actually see it properly, right? So now we have the right order. Now this one is still not finished, the preprocessor, but you know, I'm just gonna hack it until we are ready to implement it properly. So it's just really hacky, right? But this should be actually the statement. Data int is redefined, and it should point to our file, not to the standard library. So 0301, and let's also add int redefined. So yeah, let's go back to Typechecker. So we had a bit of a trip there, but it's fine. Usually, like in Cool Compiler, I was having this function that was checking the error and then a function for the error. So here, for example, I was checking if it's redefined and then, which I like more, to be honest. I like that approach more. So I think I'm gonna have the same static int is data redefined. Is data redefined, but it's like stack type checker. I mean, when the functions are static, you don't really have to put the prefix. But since I'm doing a single file, you know, I'm gonna do that. So okay, so this is the bulk of this function. So stack context, and there's string slice name. And here I can do return 1, return 0. Or I guess it's a boolean. True, false. And here it's unreachable. It's like you cannot have an error on get in this case, basically. Yeah. So then this function is gonna come here with this thing, and here inside of this is what? Stack type checker is data redefined. And I guess I need to call to continue, like in cool. right? I don't really remember. I think this was setting like the, no, not really. I'm surprised I don't set some kind of error if this happens. But I should have done that, right? Oh yeah, I do. Yeah, anyway. It's kind of weird, but okay. So Typechecker failed, right? And here we append if it's not failing. I think that's right. And this function stack append data, we don't need it. So yeah, again, I like more this approach of having a function that checks for an error and then a function that prints the error, or a define. I mean, it's whatever. But yeah, we check if the data types are defined. So at the end of this one, we should have a list of all the datas. And we can do the same for functions, I guess. At the same time, I think stack st func. Okay, so we check if func is func redefined. Func exists, right? And if it's okay, we just append it. So we need these two functions. We'll need some more some more stuff. So let's stack type checker is func redefined. We have a name and then funcs, right? And then error func exists, func is redefined, and whatnot. So at this point we can also check if we redefine function. Oh shit. I'm curious why it failed. Because it shouldn't. I guess this is a stack context func. And this is a stack context data. So I have to put something different in them. Wait, what? How did it work though? That's so weird. Stack context data and stack context func. Yeah, it's so strange. I mean, here it worked because it's the same size, but let's create huh huh I mean, I guess for functions it's not enough to check only if it exists, but we need to check more stuff. And obviously for data it's kind of enough. So I could say something like wait, what? Stack st data was the type actually? It's something like stack context data, right? Yeah. Stack context data like this, and we have name is equal to data name value. Right, I can do that. pretty easily. But for functions, it's not really gonna work. We need to check more stuff. Well, I guess even this one, stack context data, C data, let's call it. So here C data dot name is equal to data name value because it was fine. C data. And here we can have stack context function cfunc, right? And I don't know, cfunc dot name is equal to func name value. So we can just append it. But here is like to do add args and stuff, right? We have to add all the arguments. No, it's still not working. What? Is function redefined? Oh, yeah, I'm doing a fucky wacky here. Here it's stack context data. I guess I was just lucky with the stack context func item dot name. Alright, so it's still working, right? But here we need to add arguments. Then we have something else to do for data. For data that works, we need to add the constructor and the field getters. So that's something else we need to add inside of the dynamic arrays that we have. So yeah, that's interesting. And here, if a function is fine, I would also add the arguments and the returns, right? So yeah. Wow. VG course, we had a bunch of fails. 02 func redefined the SL. So if I do function, I don't know, like sum, and then I have another sum on even on 3 integers or something, it should complain 02 func sum redefined. And if I do, like, let's say plus somehow, oh, I forgot to import std_lib, right? Because it's gonna complain that we don't have int defined. But yeah, function sum is redefined. That should be 02 func redefined.ref. It should say that on 7.6 function sum is redefined. Here, yeah. So if we run checker, we should get some other errors. So yeah, here we need to do add constructor and field getters, right, as functions. Here we need to add arguments and rets plus, like, check they are defined, I guess. But how are we gonna check like type arguments, like if you have a generic function with a's and b's. Plus how to check a's, right? Oh, data redefined doesn't work. Why is that? 3656. I guess I put another line or something. Oh yeah, I added another line. Okay, yeah. So now it should work just as fine. So yeah, I don't know how we are gonna check for the A's and like generic types, because if you check stdlib, we have generic types. So we might just assume that those are generics. Like in Haskell, for example, yeah, it just assumes that that's a generic type if you put a random string, because like type checking in Haskell is pretty good. So if we can simulate that, that's gonna be really nice with the generic stuff with A's and B's. No, with like type T. You don't know what T is, but it's a type. So we can't really check if the types are defined then. Maybe like types can be generic, so no check exists yet. Unless we start having some convention about like types should start with capital letters, but no, I like the idea of being able to have a data like this. Like that's, I don't know, it's fine. Having the possibility of having emojis as type, that's cool. So yeah, I guess that's the beginning of the type checking. We'll do inference at some point. Hopefully, like if we are able to finish the context, initializing the context, we might be able to start on the inference, but I have to check a bit on inference to figure out how to do it. So yeah, but it should be interesting. Like we just have to add the arguments here and then the functions for data types here in the context. So that should be that for functions that are not external. um, or I guess for data that are not external, because if they are external, we cannot. I mean, no, we should actually. Yeah, no, like if data is external, you cannot have constructor or getters for it. It doesn't make sense. But if functions are external, it makes sense to generate the context. So yeah, I'm not sure what, but we'll see. I feel like it's important to store the data types in a list. Maybe it's gonna be useful for inference. So yeah, we'll see. But now we are working on type checking, which is what I think is gonna be interesting. So yeah, let's see if the program still, like the tests are still passing. Let's just double check. I mean, test cases are not that great, but it is what it is. rule 110 still works, I would say. So yeah, maybe we can even have some intermissions. At some point we can add syscalls, and yeah, but I'd say it's pretty good progress. So yeah, let's check next time how we are gonna continue with Typechecker. So see you then.